Good morning, friends. Here we'll start the heat exchanger course. Okay. Here we say heat transfer in a heat exchanger usually involves convection in each fluid. That means the exchange of heat in the fluids. You can see it's a convection and conduction through the wall separating the two fluids. Okay. Transferring heat from one fluid to the another fluid. Obviously the heat is exchanged through the wall of the separating those medium. We have to separate the fluid. Obviously it depends upon the which types of exchanger we have, depends on considering the particular wall. Here we have the symbolically we shown the cell and tube heat exchanger. Here we have the tube inlet, here we have tube outlet, here we have cell inlet, cell outlet. This cell, here are the tubes, here are the baffles. Baffles are used to increase the heat transfer area, it creating a turbulence. Okay. Likely, here we have the tube side flow from the right to left, and cell side flow is from left to right. Likely we can say it's a counter current operation. That is the part of the classification, but considering the overview of the heat exchanger, we can see this diagram. Here the classification. Simple type of heat exchanger means example as a double pipe heat exchanger. Okay, we have the tube inside the tube. Likely we have a double pipe heat exchanger. Compact heat exchanger, cell and tube heat exchanger, those we see in an introduction. On the basis of direction of flow, first parallel of co-current, in which the both fluid flows in the same direction. Okay, suppose if we say the double pipe, then inside the inner pipe and the annular space of the inner pipe and the outer pipe, both fluid flowing in the same direction. And if we're talking about the considering the cell and tube heat exchanger, then cell side and tube side both fluid flowing in any one direction, likely the parallel flow heat exchanger. Counter current, in which the flow are opposite to each other. Suppose one fluid is flowing from left to right, another fluid is flowing from right to left. And the third one is the cross flow heat exchanger. Here we have this arrangement, or we can say the considering the types, considering the classification, we have the arrangement likely. Here the hot fluid, suppose it in a inner tube or inner pipe, then it flows from hot fluid in to the hot flow out likely. Okay. Then considering the cold fluid, it flows likely. Here we have the parallel flow arrangement. Okay. Now, for this parallel flow arrangement, obviously initially hot fluid temperature is larger as compared to cold fluid temperature, and as heat exchange occurs, we have the changes in a temperature of hot fluid and the cold fluid. Here the hot fluid gives its temperature to cold fluid, that's why its temperature goes on decreasing, and cold fluid gain the temperature from the hot fluid, that's why its temperature here initially we have less temperature, and at the end we have the somewhat larger temperature than the initial. That is the, we can say, the exchange of the heat. Here from this graph we can clearly mention, here the arrow shows the operation is parallel flow. Considering the counter current, suppose the tube side fluid or inner tube fluid is flowing from hot fluid in, hot fluid right to left, and the cold fluid from left to right. That means it's a mode of, we can say it's a counter current mode of operation. We have the flow arrangement likely. In this case, how we have the exchange of heat, here we see. Hot fluid gives the temperature, that's why its temperature goes on decreasing. Cold fluid gains the temperature, that's why its temperature goes on increasing. Here arrow shows the operation is in counter current manner. Here it is easily observed the hot fluid temperature goes on decreasing and the cold fluid temperature goes on increasing. Considering the third type based on the flow pattern is the cross flow. In cross flow, here we have the arrangement likely. Suppose hot fluid from flowing in any direction, but we say it's in the horizontal manner, and the cold fluid, suppose it in a vertical manner. Likely we have the cross flow arrangement. Then, to have the overall heat transfer coefficient, first we have to see this diagram. Here we say the heat exchanger typically involves two flowing fluids separated by solid wall. Now here we say which solid wall we have to consider. Suppose this is the inner pipe. Its outer wall, its wall is a solid wall through which how the heat is exchanged, that we have to see. For that, here we have to heat transfer through the thickness of this tube wall, inner wall, wall of the inner tube. Then if we say the annular space, in the annular space we have the outer fluid. In the inner tube we have the inner tube. This is the outer tube, this is inner tube, and considering the area, here we have the pi dOL, pi dL. Here the L is the length of the tube, and the dO and di is the inner and the outer diameter. Here we can clearly clear our concepts. Here we have to exchange the heat. To exchange heat, we assume in the inside tube, inner tube, we have a hot fluid, and in outer tube we have cold fluid. That means we have to exchange heat, or direction of flow of heat is from the inner tube to the outer tube. Here that means we say it's a Ti to Tu. Okay. Here the arrow also clearly shows how the transfer or the direction of heat in the exchanger. Here we say the Ai is the inner cross-sectional area, Hi is the inside heat transfer coefficient. Here we have that much is the thickness, or that much is the wall. Then A0, or we can say AO, is the cross-sectional area of the outer tube, or considering the outer wall of this inner tube, and HO is the outside heat transfer coefficient. Then here we have the resistance, we can say resistance to the flow. Okay, from Ti to the wall, that means considering the convection, considering the fluid to fluid. Here we have the resistance likely Ri is equal to 1 upon Hi into Ai. Considering the wall, here we have the R wall, and considering the outer side we have Ro is equal to 1 upon H0. Okay, here we have the total resistance likely. Then the overall heat transfer coefficient is calculated likely the rate of heat transfer between the two fluids Q is equal to delta T upon R total is equal to U into A into delta T. U is the overall heat transfer coefficient and Q is the we say as a rate of heat transfer between the two fluids. Okay, here we have the just rearrangement of this equation. Likely we have equation to calculate the overall heat transfer coefficient. Then numerical based on this, here we have the statement. Here you can see this in details. The stepwise solution is provided and we have the calculation. Here we have some assumptions in diagram, and here we have the calculations of overall heat transfer coefficient. Okay, thank you. That is about the introduction of heat exchanger.